SQL, the abbreviation SQL stands for Structured Query Language. Now the name itself tells a lot about what kind of language or code is this, right? It's a structured query. Query, what do you understand from query? What is a query? Say in English terms. What do you mean by query? Yes, exactly, Cycle. Query is a question, right? So think of SQL as you have some data somewhere, okay? You have some data in the form of table. You're going to ask a question to the data in the form of a code, and the data is going to give you the answer. For example, let's say the data is, again, I keep going back to the e-commerce example. The data is for a store which I'm running, and then I want to ask the data, how many orders were processed last month? So this how many orders were processed last month should be in the form of a structured language, right? That is the query. That is one. Not only that, there are different uses of this structured query language, which we will talk about more, right? Now, what we are going to cover today is 6 things. First up, we are going to cover what is SQL and what is relational databases, right? On which this whole SQL is based off, which is very, very important, because until and unless you don't understand what a relational database or what a database is, you won't be able to understand how SQL functions. Second is normal forms. We'll talk more about it when we come there. Third is the different data types that we can use in SQL. Like with Excel, we can use different data types like float, integer, number, boolean, different things. Fourth is types of SQL commands, which means what are the different types of commands available in SQL, right? Fifth is how does the SQL query execute, which is a little different from any of the other languages you might have seen. We'll talk more about it. It is interesting. And finally, we will run a small piece of code towards the end of the session by using the select command, right? Now let's see what exactly SQL and relational database is. As I said before, SQL stands for Structured Query Language, okay? SQL lets you access and manipulate databases. SQL became a standard of, this institute in 1986. This is just for information. You don't have to know it, but I've just put it there because SQL is like started in, I'll come there, Sagar. I'll come there. SQL started sometime in 1970s, and then, it became the standard. Now, why did SQL start, right? Why did such a language begin? So it's a very interesting history. In the 1970s, 1960s, right, the digital age slowly started becoming real, right? There was a lot of information getting generated. So what people used to do is, let me open Excel. The best way for people to store information was in the form of table, right? If you, even without computers, right, if you had looked at an order book of a shop, if you had looked at any kind of information which, a business is running, you would see that mostly it is in the form of tables, right? Yes or no, right? So what used to happen was, let's say there is a date, there is order ID, there is customer name, there is sale, and there is, let's say, quantity, and maybe the product name. So if you had gone to some, some shop or whatever, right, some factory, this might be the entries, right? Let's say 17/08/2020. Right, and some product name XYZ. Okay, now this was a typical way of storing data, right? Now just imagine every day you're storing more and more and more data, right? So you need a place to store this kind of data, right? Now database, what is database? Database is a place where you store data. Okay, back in the day, people used to store data in a tabular structure, right? So most of the data that you would see today in today's industry also has a tabular structure. That means there is a database. Let's call the database as database X. Okay. What is a database? A database is a place where you physically store data, right? That is a database. Now there are different kinds of database. It can be a database which has a n different number of tables, right? This is one table. Let's call this table A. Now there can be table B also, table C. Like how you use, we did it in Excel, right? There was an orders table, there was a returns table, there was a people table. The table A, B, and C can be a part of a database. Okay, it's a place where, data is stored. Now, what is RDBMS? RDBMS is if table A is related to table B, if there is a relationship between table A and table B, then it is called as a relational database, which means that database has relationships between the tables. That's why it is called relational. Okay. Now, over the past 10 or 20 years, the database technologies have also improved, because just imagine the scale at which the data exploded after the dot-com burst was huge, right? So these kind of tabular structures, even though it was easier to just sort of store data, it was not efficient. And now you have something called graph database, all belongs to kind called NoSQL, which is not only SQL. I'll come to it. But the key takeaway here is you understand what a database is and the tables inside a database, right? Now, what all can SQL do? SQL can execute queries against a database. Whenever I say query, right, I mean query is a piece of code or a question, okay? So you might hear me always saying query, query. Whenever I say query, it's just a piece of code. That is like the language that we use when talking about SQL, okay? SQL can execute queries against a database. That means if I have a database with different tables, I can write a piece of code which will run on that table, okay, or a database. SQL can retrieve data from a database. Again, if I want just some piece of information from the database, I can retrieve the data using SQL. SQL can insert records in a database. Now you saw me inserting records, right? Writing new records on Excel. SQL can actually insert records into a table, okay? It can update records. When I say it, that means I can write a piece of code to actually insert a new record or new row into the table. I can write a piece of code to insert a new column into a table. I can delete some columns or rows. I can create new databases. Very important, right? SQL can create new databases. Now, for most of our sessions on SQL, we will be focusing on data manipulation. That means the tables and database is already created, and we'll focus on what we can do on that. If people are interested in data engineering, then it's a different story, right? Because data engineering is a huge field in itself, where creation of databases, storing of databases, or storing of data is very, very important. That kind of, but we'll not concentrate on those kinds of skills, although I will touch upon it. But data scientists will have skills of data analysis and data modeling rather than data engineering. That's not a key skill that you will need to have, but you need to know. Okay, it can create stored procedures. Again, stored procedures is advanced, but I'll tell you what stored procedures is. Let's say, for example, every week you want to run a report. We saw VBA and macro, right, in Excel. Think of stored procedures like that. Let's say if you want to do something over and over again, then you would write a stored procedure rather than writing the SQL query full code. That is one. Second is you can create your own function. For example, let's say you're a teacher or you're running a school, and you conduct 4 exams in a year, and the final exam for 100 marks. And then what you do is at the end of the semester, you average everything and then add up, right? So what you can do is you can actually create a formula to do it and store it in your library. And whenever you want to just calculate the final result, you can call that procedure and run it, right? So think of it like predefined user-defined function. Create views, more on it maybe in the session 2 or session 3, but I will do it later, right? Now at this point, it's not so important. And lastly, SQL can set permissions on tables, procedures, and views. So what does it mean? Let's say, for example, you're working for a bank, let's say HDFC Bank, right? Now, HDFC Bank has a lot of customer information, correct? And this information has to be very, very secret, right? Only a few people can actually access the information. Not all employees of HDFC should be able to access this information, correct? Now, HDFC has one database which has different tables. It has customer information, it has transaction information, it has marketing information, it has its own finance information. And HDFC also, now the bank itself has different teams, right? There will be an engineering team, there'll be a marketing team, there'll be a finance team, so on and so, there'll be a HR team. Now inside HDFC, since there is just one database, you want to make sure that only HDFC finance people will have access to this information, right? So what SQL allows you to do is, it will allow you to set permissions on tables at a tabular level. That means even though it's a big database, for example, let's say this table A is very sensitive information. Table B is general information and table C is non-sensitive. Now, all these tables form database X. But table A, which has sensitive information, is accessible only by finance organization. Table B is accessible by all. Table C is, let's say, finance plus market. You can set permissions on different tables. Who can view, who cannot view, things like that. Now, all this will actually, be more related to your data engineering side of. Okay. Now, briefly, we spoke about a relational database, right? Look at this table. There are three tables that you see. There is an order item table, there is a customer table, and there's a transaction table. Okay. What is common between order item table and transaction table? What is common between order item table and transaction table? Order ID. And what is common between customer table and transaction table? Customer ID, right? Okay. These three tables form one database, but there is a relationship between the order item table and the transaction table, and there is a relationship between customer table and transaction table. Now, let's call the order item table as table A, transaction table as table B, and customer table as table C. Table A is related to table B, and table B is related to table C. Is table A related to table C? No. Yes, right. A is related to B, B is related to C. So A is related to C, right? Basic math. So that means these tables have a relationship between each other. I mean, there might be a fourth table which is not related to any table, but that's fine. Okay. Relational databases are the ones where tables are related to each other. Saurabh, I'll come to transitive. Don't jump the gun here, right? I will talk about that also. Now let's look at the definition. A relational database is a type of database that stores and provides access to data points that are related to one another, right? Now these are related to one another. And relational database, what you see here is a tabular structure, which means the data is stored in the form of tables. In this relational database, each row in the table is a record with a unique ID called the key. For example, if I say, this item ID 5 represents this whole row, the first row. Item ID 6 represents the second row. Item ID 7 represents the third row. This is called the key, right? The columns that you see, it holds the attributes of this data. What does attributes mean? It means nothing but fields. It has item ID, order ID, item and amount, right? Now, there are some popular examples of relational databases. Some of the examples I've listed down here. Of course, it is not everything, but some examples are Microsoft SQL Server, Oracle Database, MySQL, PostgreSQL, and IBM DB2. These are some of the platforms that allow you to work with relational database. We are going to be doing MySQL, and 99% of the code will be common across all these platforms. Okay, I chose MySQL because it is open source first, which means it is free. All the others are not. Okay, and that's the reason why. You don't have to worry that, okay, I just learned MySQL. What about Microsoft SQL Server? You can use almost same piece of queries and codes with not much changes. Now, this is a tabular structure, right? So after 2000, what people realized was it was getting difficult for software developers to actually create these relationships and store data. Why? Because I don't know how much you know about agile methodology, waterfall methodology of software development. Between 2000 and 1990 and 2005, software developers used to follow the waterfall methodology, which means even before executing something, right, they would actually write a blueprint of this whole structure. Now, we are just seeing three tables here, but in a company, let's say like Amazon or Facebook, just imagine the number of tables and the number of relationships between the tables that have to be formed by software developers. It is massive and it is complex. What happened was, once you define this structure, right? Once you define this structure, this is very rigid. Okay, you can't, let's say, order item table has 4 columns. Now, tomorrow, if you want to add a 5th column, then you have to redo this whole structure again. So if there is something horizontally added, it is going to be very difficult for software developers to do it. It is going to be very complex for them to do it because they have to rebuild this entire relationship. They have to create new relationships for that particular column. So that was the challenge in relational databases of tabular structure. So what they decided was they came up with a new structure called the NoSQL.